Okay, I'm going to do a video covering some problems in 5.8. I'm going to look at those 4 questions on your study guide that it was recommended that you do. And then I'm also going to work through the 2 problems off of the integration test. All right, so question number 3 that was in the book in section 5.8 that they recommended that you do look like this. Okay, so first thing you're going to do is notice that it looks like it's going to be an arc sine. Oops, let me write that better. Looks like it's going to be arc sine. It's got the square root in the bottom. It doesn't have that extra little variable out in front here. So it's just going to, if it's going to fit anything, it's going to fit arc sine. All right, so then you go pull that arc sine formula that says this. Okay. All right. Okay, so what we got to do is we got to get what we have over here to look like what we have over here. So we have to figure out what actually got squared in the denominator to make the 9. So here we have that this would be 3 squared minus the x squared. Okay. All right. Now this one then fits the formula exactly with a equaling 3 and the u is really just x. Okay, so even if you did the du thing, you would just get 1 dx. So you don't really need to use the u substitution concept because it is just x right here. Okay, but anyway, you can think of it like that if you want. And so and put in the u's if you want, or just leave it like it is here. So now you're just comparing to the formula, and you know that this should equal the arc sine of u, which is x, divided by the a, which is 3, and then don't forget to put the plus c on it. Okay? All right, so that one right there didn't have any of the substitution issue to do. It was just really trying to identify what was the a in that formula, and then you're basically done. Okay. All right, so that was question number 3. Make sure I copied that right. Yeah, I think so. All right, now let's go ahead and look at the next one they recommended you do. Okay, question number 5. There it is. All right, so taking a quick glance at this one and comparing to the formulas, this one looks like it's going to be an arc secant situation. All right, now this is the one where I feel like I really didn't do a good job on how to handle the fact that what's getting squared here under the radical is actually 2x getting squared. Okay. So I want to talk more about the way to think about that. Because the formula for arc secant that you're using, when you compare to it, says this. Let me write small right here. Secant, absolute value of u over a plus c. Okay. So the issue is really this piece right here. That's what I don't feel like I emphasized like I should have. All right, so let's look at question number 5. So looking at this, we can see that a should be 1. We can see that u should be 2x. Okay. All right, now the way we've been handling the switching from x's to u's on all the other integration problems is we would come in and do du, and then over here the derivative of 2x would be 2, and then the derivative of u with respect to x, we would really be that, and then we wrote it in differential form. So we got to where we just wrote it like this: the derivative of u equals 2 dx. Okay. All right, so I wanted to try to explain then what you got to do about this right here, and also what you got to do about this right here. So we have a dx, not a 2dx. So the way we did it in earlier problems is we would just get rid of the 2 by dividing on both sides. So I know right there I can put 1/2 du. Oh, and by the way, the dx written over to the right is the same as if it had been written right on top because of how fractions get multiplied. Okay, so I can replace the dx with 1/2 du, okay? And then I think it's pretty clear under here that you would have your u squared minus your a squared under the radical. So that part's not bad. Let me move that 1/2 du up just a little bit because I want it to be right here. The part that sometimes happens is right there. I need to get that x to be a u. And so here I can use this formula and I can see that x would equal 1/2 u. Okay. All right. So what I had before with the x's in it now looks like this when I have the u's in it. And what I need to do is do something about the fact that my formula doesn't have all these constants on them. But, I can bring those constants out in front, or look at this really. So this 1/2 is really up on top. This 1/2 is really on the bottom. So this really is equal to 1 over u, square root of u squared minus a squared, du. So now we do have it transformed into the formula exactly, okay? And I kind of glossed over this piece right here because it turned out not to matter that much because of the constants canceling out. So I may have glossed over that and not really emphasized like why that happens. I also want to show you one other way to get from the x's to the u's that maybe might make more sense. We didn't do it this way back with the others, but it works kind of nicely here, and you might appreciate the added simplicity. All right, so right now we basically have the dx on top, right? 1 dx. This is really basically on top. Down here we have the x with the square root of this 2x squared minus 1 squared, okay? So the thing is, instead of doing this business that we did before, here and here, what I could do is adjust so that I have a 2 dx on top by multiplying the top by 2. But if I do that, I would have to multiply the denominator by 2. Otherwise, I've changed the problem. And then this is very convenient, isn't it? Because then this piece is really du. And right here, I really have a u. And then I've got the rest of the stuff that I already understood, which is that this would be u squared minus 1 squared. So that's another way to resolve the issue of having that x right there. Let me do it in this x right here and this dx that have to be switched to u's. All right. Now, once you get it all switched, you know what the formula says. It's basically in the form it needs to be in. So the formula says this would equal 1 over your a arc secant, 1 over your a arc secant. Then it's going to have the u divided by a and then plus c, right? So it's just that formula right there exactly. But u was equal to 2x. A was equal to 1. So we're going to put those back in. So we really just have 1 over 1 arc secant 2x absolute value over 1 plus c. And that simplifies a little bit, okay, to just arc secant absolute value of 2x plus c. And you're done. So that was the second one on the problems out of the book that they recommended you do on the study guide for the final. Okay. All right. So let's try another one. All right. Now, this one, I'm glancing at this one and I'm seeing that there's no radical. So I'm thinking arctangent. So then I'm going to go to the arctangent formula and I'm going to think how to make it look like an arctangent situation, right? So you're going to go pull the Arctan formula and write it down. Okay. So the Arctan formula starts off with a 1 over, well, actually, they usually write it with the du over the a squared plus u squared. And what it turns out to be is 1 over a arctan u over the a plus c. Okay. So I need to get what I see over here to look exactly like what I see there. Okay. So first thing you do is you think about how that denominator is really 1 squared plus 3x all squared. Okay. And then over here, I didn't have anything up on top besides the du. So one way to handle the issue with the 12 is to just pull the 12 out. Because remember, it's always okay to do that with constants. Just get it out of the way for a minute. Okay. And oh, I forgot on number 6, it has the dx over here or up on top. I can't remember which way it was. May have been up on top. I don't remember. I don't want to go look it up. The dx would have been somewhere, either up on top or over to the right. Okay. So we have like 1 dx up on top now if we pulled the 12 out in front. All right. So we may want to do something different with the 12 once you kind of see what happens, but this is one way to handle it. Just pull that 12 out of the way for now. Okay. All right. So then we can see again that a is 1, the u is 3x. And if we did the derivative of u with respect to x, we would wind up getting du dx, but we're going to do the derivative of the left side and then the derivative of the right. So we'd have du equals 3 dx. Okay. So what I know is that dx is really 1/3 du because I can divide both sides by 3. Okay. All right. So that means up here on top where the dx is, I'm going to replace all that with 1/3 du. Okay. Then on the bottom, the 1 squared, that's going to stay that way because that's my a, right? That's my 1 squared. But then in place of the 3x, I'm going to be putting my u and squaring it. Okay. And then don't forget that you have a 12 that we dragged out in front earlier. Okay. Well, the 1/3 that I have up on top shouldn't be there if I'm looking at this formula right here. So why don't we pull that 1/3 out with the 12, and wouldn't we have 4 really out in front of all of this? Okay. All right. So now I've got it looking like it's supposed to look, and I'm ready to use the formula. Just don't forget that you'd have this 4 really already out in front. Then you're going to multiply by the 1 over a, which happens to be 1 over 1. Then you're going to do your arctan. And then the u value was 3x. You have to divide by a, which happens to be 1. And then you add c. Okay. So you're going to wind up getting 4 arctan of 3x plus c on that one. 4 arctan of 3x plus c. Okay. All right. So that one wasn't too bad. We just had to do something about that constant, that 12. And that's actually the piece of it that I wanted to show you that I was hoping would help. Okay. All right. Now, trying to find the next problem on the study guide we have to do. Okay. And also, I might show you up here. Some of you might have waited on this one and dealt with changing from the dx to du slightly differently. Like what we could do is do all of this first and notice that we need 3 dx. And so we could have left the 3 on the dx and only pulled the 4 out because of it originally being a 12, and then had our 1 squared plus 3x squared, like that. Okay, so we could have done that instead, and then this would become the du, and we'd have the 1 squared plus u squared, and we'd go from there. Okay, so just a quick comment about that. All right, so far, we're just trying to do the problems that were listed on the study guide from section 5.8. So there's one more. This one was question number 11, t over t to the fourth plus 25. Okay, so I'm looking at that one, and I'm feeling like that one's going to be an arctan, if anything, because it doesn't have the radical in it. Okay, and for it to work, I need to figure out, or for me to use the formula, I need to figure out what really was getting squared in each term down there to make each term in the denominator. Okay. All right, so this is what I've got. So that means my u is going to be t squared. My a is going to be 5. Du would be 2t dt. Okay. All right, now the formula for arctan, we did it earlier, has that if you had dx, du, over the u squared plus a squared, that's going to equal, and then remember up on the formula how this one has that little 1 over a in front, okay? So you got to do that kind of like you have to on the secant problem. So you're going to have the 1 over a, and then you're going to have the arctan u over a plus c, okay? All right, so this one's kind of interesting because we have this t squared. We had this extra t right here that at first you might think, oh no, what am I going to do about that? But it's a good thing that we had it, because when we go to put our du in there, we see that we have to have a t along with the dt. All right, now maybe we'll try to do this one, that other way I showed you to do the to handle the du's that involve an extra constant. Whenever you have an extra constant, one thing you could do is get that 2 back in there by just putting a 2 there. But if you're going to put a 2 there, then you're going to have a 2 here in the denominator. Okay. All right. So when we go to replace things, this whole 2t along with the dt is going to be able to be replaced with the du. Okay. But then in the denominator, what we have is this extra little 2 out in front. Then we know right here we can put a u. Oops, not writing. We can put the u, okay, and square it. And then here is where we have the a getting squared. And that 2 is actually being applied to all of that. Okay, so what I can do now about this 2 right here is just move it out. It's in the denominator, so it's really a 1/2. Move it out in front, and then you have something that matches now perfectly to the formula. But don't forget about that 1/2 you moved out. You're still going to need it. Then you're going to do 1 over a, which is 1 over 5. You're going to have your arctan, the u, which let's go ahead and put the u back in. The u, which is t squared, over the a, which is 5, and then plus c. So then you just need to clean up a little bit, because the 1/2 and the 1/5 would be 1/10. Okay. All right, so I wanted to show you that. That's one way you could have handled having that extra constant. Of course, you could have done the 1/2 du equaling t dt and had that 1/2 du on top without adding that constant on the bottom. Okay, and then you would have still pulled out that 1/2 out in front, wouldn't you? Okay. Oops, I meant to have a u there. Okay. All right, so that's those 4 questions that were on the study guide. And then there were 2 questions on test 4 related to this. So let me do those really quickly. And then I'm going to have to stop and I'll do another video later on some other problems. So question number 18 on the test was 4 dx over 9 plus 16x squared. And you're trying to integrate that. Okay. All right. So you think about the denominator being 3 squared plus 4x in parentheses squared. And then let's see about that 4. Maybe that 4 is going to be a good thing. So don't do something with it yet. You're going to let u be 4x. The a is 3. The du would equal 4 dx. So see, we actually have what we want right there. So now that can be rewritten as du over 3 plus u squared. So now that fits the arctan, doesn't it? It doesn't have a radical, so it fits the look of the arctan. But notice in the formula that normally it has the constant at the end. So make sure that for you, you're treating it as the piece of this that has the variable. Okay. But those could be in either order. All right. So the answer should wind up being, that should have been a 3 squared there. Answer should wind up being 1 over 3. Okay. Then arctan. And then the u, which is 4x over the 3, and then plus c. Okay. All right. And then one more is question 19. And that one has that x with a radical in the denominator. So you should be thinking arc secant, shouldn't you? All right, so let's get it looking right before we figure out what we're going to replace. Okay. All right, so let's see. I'm going to let u equal 5x. Then du would equal 5 dx. And then we can see a is going to be 8. Okay. So we got a couple ways to handle it. I showed you 2 ways to take care of this extra little 5 that we need. One good way to do it is throw the 5 on the dx. As long as you throw a 5 in the denominator, you'll be okay. And then that helps in another respect, because then down here, you're able to use the u for this 5x, extra little 5x piece. You don't have to put a fraction in there. Then we'd have u squared minus the 8 squared. On top, 5 dx is du. This is exactly the formula for arc secant. Okay, so for arc secant, we have to do 1 over a. Okay, then we wind up doing arc secant. And we have to wind up doing the absolute value of u, which is 5x, okay, over the a. And then we have plus c, okay. So you might have thought you needed to have 1 over 40 or something like that, because you did the 1/5 du equaling dx. Okay, but if you did that instead of what we did, then up there on top you would have had a 1/5 du, and under here you would have had the u squared minus the 8 squared. The problem would have been that the x would have needed to been, let me change it to green, this x right here would have needed to be rewritten as 1/5 du. So there would have been a 1/5 u. Okay, so there would have been a 1/5 down here as well. And so really it would go away. Okay, so either way you were thinking about it, you don't really get a 1 over 40. You just get a 1 over 8 when you're finished. All right, so I'm going to stop this. This is just a video covering the integration problems that are in 5.8. I did the 4 from the study guide for the final and the 2 that were on the test.